Hey, it's Till, and in this video we will be programming a simple brute force app with Java and IntelliJ IDEA. Before we start with the program description and implementation, we should clear up what brute force is. Brute force is a kind of attack on something where you try to crack it open by trying any possible combination on it. Like for example, try every combination on a safe, or in case of IT security, try every possible word as a password to get access to user's account. We are more interested in the second case of guessing a user's password by trying every possible combination. Our brute force program will generate every possible word and in a simplified way try it against the chosen password. We won't be using any hashing of candidates or a hashed password to check against, but this would be easy to implement if needed. Let's write down the requirements for our brute force app. First, create all combinations of words for a given length from a predefined set of legal characters. Second, try all those password candidates against a given password. The bulk of the work will be creating those candidates. Let's start with the predefined set of legal characters requirement. For this we should know what ASCII is, as our whole set of characters will be defined by a subset of the ASCII character encoding. Let's open a table to see what the ASCII character encoding is. The ASCII character encoding describes how a character is to be represented with a single byte, actually with 7 bits. 7 bits can define any number between 0 and 127. The ASCII table sets control symbols, letters, numbers or symbols for any number between 0 and 127. The number can be seen in the decimal column. The control symbols occupy the first 32 numbers. After that come the printable symbols, which we will be using for our word generator. The interesting ASCII codes for us are thus numbers 32 to 126. Here we will use the property of the ASCII table that we can just increment a symbol's value to get the next symbol and roll over again to 32 when we reach 127. Start a new project by going to File, New Project. Call it brute force and select JDK17 download right from the menu if needed. Click create. Navigate on the left side to the main source file. We will start by defining our character set limits. For that we will define 2 variables that will hold the limits for us. A variable is something you can save something else in and reuse it at a later point in the code. Let's define the lower limit and the upper limit. Both are of type int, which means number. They are set to the corresponding ASCII values. We could use the numbers 32 and 126 directly in code and it would work. But by using variables we have the benefit of giving those numbers a meaning in our code by giving them a good variable name. So now we have a lower and upper limit which defines the to be used symbols of our character set. We will add another variable called given password that will be used as a password to be brute forced by us. The special thing about this variable is that it is an array. An array does not only contain a single value for a given type but can contain multiple values of the same type in a single variable. Think of a word like hello. This is actually an array of letters where you can look at each letter individually by saying give me the letter with index 1, which would be the second letter E as indexing starts with 0. Think of arrays as lists of the same thing. We will set the given password to till, a 4-letter word, as anything above that keeps the CPU busy for too long. Unless you have a supercomputer like me. The password till will be saved as a character array. Okay, so we will now start generating our password candidates. To do that I will split the problem further down into generating first all 1-letter passwords, then all 2-letter passwords, then all 3-letter passwords and so on. Splitting the password candidates into lengths 1, 2, 3 and so forth helps with array comparison when we actually want to know if candidate and actual password are equal. To create password candidate lengths we will use a for loop to create the numbers 1, 2, 3 and so forth. A for loop works by defining a variable as a starting point, then checking a condition on that variable if the loop should cancel, and if the loop does not cancel, then do something with the variable. In our example, we will start with number 1. Check if the number is smaller or equal to 5. And if it's not, then increment the number. Let's check the loop out by printing the variable. As you can see, it's counting from 1 to 5, and this is exactly what we need to create password lengths from 1 to 5. The next step is creating a variable to hold the current password candidate. For that, we create another array that is as big as our loop variable number of letters in password. The array's length is given in the square brackets. The array will start empty, meaning it will initialize every value in it to the default value of the character type, which is 0. What we need is to initialize our candidate to the starting point defined by our lower limit variable, meaning we want value 32 for every position in our array. The array fill method does exactly that. It sets every value to the given value we want. Let's have a look at it in the debugger. I will add a dummy statement here so we can have a look at the values. When creating the array, it is initialized with ASCII value 0. And in the next step, it is set to ASCII value 32. So let's talk about our candidate and how it's going to work. Let's pretend our password length is 2. Let's pretend our current password candidate value is AA. What we want to do is use this candidate for the password check, and if it's not equal to the given password, then we are going to increment our password candidate from AA to AB to AC to AD and so on. When we reach A tilde, where tilde would be our upper limit, we should reset the letter back to the lower limit and increment the next value, meaning we go from A tilde to BA. So much on how our candidates are generated. To increment our password candidate, we need another loop that goes through every possible value that we can create. How many values can we create? For every letter in our candidate, we have upper limit minus lower limit plus 1 of possible values we can use. Let's pretend that our lower limit is A with value 97 and our upper limit is B with value 98. Then we have as combinations the values AA, AB, BA and BB, which is 4 different candidates. When we put our values in our formula, we will have 98 minus 97 plus 1 times 98 minus 97 plus 1, which equals to 4. The 98 minus 97 plus 1 is always the same for every letter in the candidate. That multiplication of the same values can be shortened with the exponentiation operator, so we can say that the formula is 1 plus upper limit plus lower limit raised to the power of number of letters. Enough math, let's define this formula's result as our number of possible combinations that our password can have. For that, we use the math_pow method to do exactly as explained and use the exponentiation operator to calculate our combinations. Okay, so combinations now is how often we want to increment our candidate. To actually increment our candidate, we will use another for loop that goes from 0 up to the number of possible combinations. In this loop, we will do the incrementing of the candidate. Every iteration, we increment the last letter of the candidate like we said before. Candidate.length minus 1 is the last letter in candidate, and the plus plus increments it. The next thing we need to do is check if we go over the upper limit of our current letter. Remember, this is the case when going from A tilde to BA. This should do the trick. We start with checking if the last letter, candidate length minus 1, is over the upper limit. Candidate length minus 1 is the position of the last letter. If the letter is over the upper limit, we set the last letter to the lower limit and increment the second last letter by 1. This should exactly be A tilde to BA. Let's print the current candidate out with system out println new string candidate. Let's scroll up a bit. For now, let us limit the password length to 2 and 3. As else, we would run into an error with password length 1, where we cannot increment the second last letter when we reach upper limit. Start the program. As we can see, all candidates are printed out. But there seems to be a problem. It looks like as if the candidates have symbols that are not defined by ASCII. This is kind of expected as we only fix our last letter, not any other letter of the candidate. What we need to do is to also fix the second last, third last, fourth last, and so on. So let's do that by using yet another for loop. What we need to do is iterate over every letter and check if the letter is over the upper limit. To be consistent with my description of how we increment the candidate, we will iterate with the for loop in the reverse way, meaning from the last letter to the first letter. Start at the last letter. Check if we haven't reached the beginning, and if not, then go to the next letter. Letter in candidate is now the position we want to check. Let's copy over our conditional and fix it to not always use the last letter but use the current letter. Start the program again. Now it should work as expected. Comment the printing of candidate. For performance reasons, we can also return early from this loop by using an else branch to stop the loop when we do not find a character that is over the upper limit. It is like that because we increment our letters from right to left, and only in this occurrence it can happen that a letter goes over the upper limit. If it doesn't happen, then none of the remaining letters can be over the upper limit, and thus we can stop. With break we can leave a loop early. So the brute force word generator is now working. The last step would be to check against the given password. We can do that with the array equals method. Let's add a conditional based on array equals. If we find the candidate to be equal, then we are done and can return from the program. To give a little more spice to the program, we can print some nice message giving us the number of tries it needed to find the password. Let's define a new variable at the top called sum of tries. Set it to 0. We will use a long as integer only goes up to 2 billion and it could not be enough for some passwords. We will increment sum of tries every time we create a new candidate. The message we want to print will be found password with the password and number of tries with the number of tries. Let's fix our main loop again to go from 1 to 5. Okay, so remember that we set the given password to till. Let's start the program. It took 46 million tries to find the password. You can try any other password, but don't go over 4-letter words if your computer is not the fastest. Maximum 5 letters if you have a really nice computer. And that's it. In this video you saw arrays, for loops and conditionals. If you have any questions left or would like to tell or ask me something, then please leave a comment. If you liked the video, then please leave a like. If you want to see more, then please also subscribe to the channel. See you in the next one.